Hello, I'm Alex Brown, and I'd like to introduce you to the knife plate connection design tool. This tool allows you to properly coordinate a knife plate connection with the joist top or bottom chord. It does this by analyzing the plate, weld, and joist member sizes, which allows you to fine-tune each one to get the capacity you need. Let's jump in. So the first thing to point out are going to be the tabs across the top here. You can see kind of two of them are for the top chord or TC of the joist. So that'd be a knife plate design going into the top chord and seat area of a joist. And then these two are for the bottom chord, the BC. And that is going to be for like a bottom chord extension with a knife plate going into the gap between the chords. And then there are these two tabs here, REF for reference. So that's going to have all of the commentary, a few additional details, some definitions, just kind of explaining how the joist fabrication process works and how that detailing process needs to go in order to get a good connection at the top or bottom chords here. But the tools themselves, the spreadsheets, are in the knife plate TC and knife plate BC tabs here. And that's what we'll primarily focus on for this video. So at the top of the tool here are going to be these fields for project, engineer, job name, and all of these are optional inputs, and that's really just so it shows up on the final printout with all the inputs, outputs, and the calculations, just for your own organization if you need to include this in like a project calculation submittal or package, something like that. Going down just a little bit here, this tool does support LRFD or ASD design, and that's going to affect some of the symbols that are used to properly reflect the two design methods and also the methodology. So you can see that capacity of 75 kips under ASD becomes 113 kips if using the LRFD procedure. We'll leave it at LRFD for the examples that we do here. So continuing down here, this first section is going to be defining sort of the plate itself and also the weld that is being used to attach it into the joist. So you can see the different fields here for the plate thickness, the width, which is actually the vertical dimension of that knife plate, how long it's going to be horizontally, the yield strength, and then the size and length of the weld as well. And then the second section here gets into the joist girder info, it's labeled. I'll point out that the joist doesn't have to be a girder in the sense that it's supporting primary members for gravity loading. A large joist like an LH or DLH joist, perfectly capable of handling knife plate connections as well. So just want to point that out as it could potentially be misleading. But here, this is going to be more for minimum dimensions that are needed in order to make sure that connection is getting the capacity that's desired. So minimum vertical leg and minimum thickness of that leg are going to be the angle sizes of the top chord of the joist itself. And then you can also model different gaps between the joists. So it's a horizontal dimension between the joists here. It's going to default to 1.5 inches. And then top chord angle space is going to be the gap kind of in and out of the page here. So it's a horizontal dimension perpendicular to what we see here. And that's going to be the chord gap between the two angles of the top chord. And that's going to be 1 inch for pretty much any of the joists that we're looking at today. So then everything is summarized here as far as the plate connection, girder requirements, and then what capacity that results in. And then all of our underlying calculations are shown here, so you can see it checking the different failure methods for the plate, the weld, the joist, and then all of that gets summarized again. This is the same box that's up here, but then this is the page that would print out if you were to hit that print button up at the top. The bottom chord section structured very similarly, defining the plate, the weld, and then the joist information, minimum sizes. There is a drop down here for truss type for joist girder or joist, just to properly account for what the conditions might be there. And then everything printed very similarly. We've got our capacity, all of the calculations. I'll point out this disclaimer here. Check of the knife plate to column and check of column are outside the scope of this tool. And yeah, that's going to be the plate material, the column material itself. That's going to be up to the structural engineer to make sure that all of that load transfer is correct and everything has the capacity that's needed. And then there is another disclaimer here. This is on the top chord tab as well. Joist manufacturer determines final bottom chord angle sizes, or top chord angle sizes for the first one. And yeah, these are just minimum dimensions that us as the joist supplier, we would make sure our design hits. But if there's additional loading or additional conditions happening on this joist or joist girder, we're going to make sure that everything is upsized to account for that. So it's just a minimum dimension, but chances are we may supply an angle size that's larger than this. And this verbiage here This is going to be really important to put on a set of contract drawings or contract documents that are put out for bid, for detailing, because we need to get this information up front, make sure it's all accounted for and coordinated properly to make sure that we're hitting that capacity that's the connection's been designed for. Off on the side, it says weld controls the connection capacity. If we flip back to the top chord here, just with the default values that this tool populates with, the plate controls the top chord, weld controls the bottom chord. And I only point that out to say that this tool does a good job of identifying what's controlling that connection, and that's going to guide you. If you need more capacity, those are kind of the different levers you can pull in order to achieve that. So for this particular scenario, as we see it here, I'd want to focus in on getting more weld onto this connection until something else controls the capacity, and then I can start playing with those dimensions. So let's go ahead and jump into an example. We'll go back to the top chord here. And if I had played with any of these dimensions or inputs already and I wanted to just reset it and kind of get back to this default starting spot, sort of a clean slate, I could hit this default values button and that would just reset all of my inputs here. So you can see here, the plate controls the connection capacity. It's 113.4 kips here. So if we want to increase that, we need more plate. So just go ahead and start playing with some of those dimensions. You can see right away, joist girder now controls this connection capacity. We got a few more kips out of it, but really where we'd want to focus here is going to be the minimum top chord vertical leg, minimum top chord thickness dimensions here as well, because that's what we as a joist supplier have really good control over to make sure that we're providing enough material to make that connection happen. So if I start increasing the minimum top chord thickness here, defaults to 1/4 inch, but if I bump that up to 0.28, now my weld is controlling. So if I go back here, let's bump that up a little bit as well to 5/16. We'll make it a little bit longer, 12 inches. So now we're back to the girder controlling the connection. So we can continue bumping that up. And you can see it just by kind of playing with the different values here, sort of knowing where to target next. I'm able to continue increasing that capacity, increasing the strength of that connection until I'm able to hit whatever number I'm looking to achieve. And again, I'll point out that these minimum top chord dimensions here, the thickness, the vertical leg, these really need to be on the structural drawings, the contract documents, in order to clearly communicate to the joist supplier what those minimum sizes are so we can correctly supply this particular member. Let's jump into a second example, looking at the bottom chord now. So here, let's have a number that we're actually shooting for. Let's say we want 100 kips of capacity. So you can see the default values are around 50 kips for this scenario. There's this option here to show connection demand, and if we toggle that over to yes, that pops up this field here, so I can change that to whatever my number is. And that just adds this little extra check here. So 50 is less than my 125 kips, my connection demand, so it's no good, NG. We'll leave that as 100 kips for this example. And we can see here that the weld controls the connection capacity. So if I were to change, say, my bottom chord thickness from 1/4 inch up to 0.28, nothing's happening here. So again, this is a really helpful piece of the tool to guide you into what actually matters, what's going to actually affect the strength of the connection. So I'll go ahead, I'll just make this weld length a little bit longer. You can see it defaults to 3 inches here. If I take that up to 4 inches, I'm going from 50 kips up to about 67-ish. If I add another inch, I'm up to 83.5. And if I add another inch, I'm up to 6 inches now. Now I'm at 100.2 kips, which is pretty much spot on with what I was looking for my demand. So everything's good here. But if we wanted to try maybe a slightly different way of achieving that capacity, you'll notice we were using 3/16 weld the whole time. If I wanted to try a shorter length of a larger weld size, I could bump that up. You can see I'm getting an error message here that the bottom chord thickness needs to be increased to accommodate the larger weld size. So I'll go ahead and bump that up in order to properly accommodate that. So now I'm well over the 100 kips that I'm looking for. So if I start backing down that weld length, so 111 kips, now I'm too low at 89 kips, so I'll put that back at 5 inches. maybe I can fine tune that a little bit more. But now I'm saving, maybe a little over an inch of weld. It's a slightly larger weld size. But the trade-off here is that this bottom chord, now has a minimum thickness that's a little bit larger than what it, could have been using that first scenario. So, the takeaway here should be to keep the economy of the situation in mind as well. Because if the entire bottom chord is getting thicker in order to accommodate, a minimum thickness, to accommodate a larger weld size, that's going to make that girder heavier potentially. That's going to add more weight to the project, add more cost to the project. So you definitely want to keep that in mind, just kind of what that reality might be, the real world impact of these different conditions. And then note too over here, just in general, it's recommended anyway to use longer, smaller welds, so shear lag and tension rupture do not control the connection overall. And that's the knife plate connection design tool. It's a great tool that takes the guesswork out of using knife plate connections with joist. Be sure to check out our tie plate connection tool for designing smaller axial load transfers. And with that, happy specifying.